Although he lived more than 2,000 years ago, Archimedes, a Greek philosopher and mathematician, is still regarded as one of the greatest physical scientists of all time. You've probably heard the story of the king's crown when Archimedes was commissioned to try to determine whether a crown was truly made of the element gold or not. And the problem is you can find the mass of the crown, but you could find the mass of all kinds of sizes of gold, and it would be different. You could also find the volume of an object, but that would be different based on the size also. But Archimedes, in his genius, discovered that if you find the ratio of the mass of an object, you take the mass of an object and you divide it by the volume of that object, and if it's made of a pure substance, then that ratio will always be the same for that particular pure substance. So it wouldn't matter how big of a chunk of gold you had. If you found the mass of it and divided it by the volume of it, you'd get a certain number. And even if you had a small piece of gold, or maybe even a crown made of gold, if you found the mass of the object and divided by the volume of the object, you would always get a constant number for that particular element, like gold. And so this ratio of mass divided by volume, he called the density of an object. So when we want to calculate the density of an object, we're going to find the mass of it. And we find that, of course, by putting it on a scale. And in this day and age, we just use nice digital scales. So we just set it on the digital scale and read what the mass is, and we record that. And then we find the volume of the object, and we record that. Now, you might want to watch the video on volume. If it's a regular object, we can use a formula. If it's an irregular object, we're probably going to use water displacement in a graduated cylinder. But nevertheless, we can figure out the volume and record that also. A good way to remember density, the equation for density equals, we can say that we love density. We love density. And if you look at that long enough, you'll figure out that density equals mass, there's an M, mass over volume. Mass over volume. It's very important to remember this. I have a lot of students that will get this turned around, and I'll see a lot of volumes being divided by masses, which makes no sense. So we love density. Density equals mass divided by volume. So let's just do a problem. Let's say we have a mass. We put an object on a scale and we get a mass of 34.62 grams. We'll say the scale had a precision of to the hundredths place. So we write down, we get a mass of 34.62 grams. It's important to write down the unit. And then we find the volume. Maybe it's an irregular object and we put it in a graduated cylinder and we see the water displacement went up 7.1 milliliters. With a graduated cylinder, we know we can measure the tenths place of a milliliter. So to figure out the density, we love density, we'll just take the mass, 34.62, and we'll divide by the volume, 7.1. And if we do that on the calculator, we're going to get, a calculator just tries to do the math and gives you decimal points all the way out to everything. But we need to use sig figs in this particular math problem. So eventually you're going to have to watch a sig fig video to make sure you understand how to do math with significant digits. This mass has 4 sig figs, and the volume only has 2. So our answer has to be rounded to only 2 sig figs. We can't have any more sig figs than whatever our least least amount of sig figs is. So if I put this in the calculator, I get like 4.87605, and it keeps going. So what we're going to call that is 4.9. That's our density. And our units are, the units of mass was in grams, and then we divided that by units in volume, which were milliliters. So we're going to call that 4.9 grams per milliliter. 4.9 grams per milliliter. Now, one thing we'll know about this is that if you remember, the density of water is 1.0 grams per milliliter. Density of water is 1.0 grams per milliliter, which means this object, whatever it is, will sink if I put it in water, because it's greater than 1. If it's greater than 1, it's going to sink. If it's less than 1, it would actually float on top. So this object, we calculated its density. We took its mass divided by its volume. We find out its density is 4.9 grams per milliliter, and that would actually sink in water. So it's a pretty easy calculation. You just got to remember that we love density, and you'll be able to always determine a correct answer.